Hey, Yusria, is my audio fine? Can you hear me? All right. For complex numbers, Yusria, just if I give you, let's say you have a polynomial p at x is x squared plus 4, and it wants all roots over the complex numbers. Let's try to solve that one. Right, you'd set this equal to 0, and you're looking to solve for x for this one here. So with something like this, in this case here, you could bring that to the other side. There's a couple ways we did it. You can just go ahead and take the square root directly, to which you get the square root of negative 4. But you remember the square root of negative 1 is defined to be your imaginary number I. So this becomes plus or minus. This should be plus or minus in front. The square root of 4 times the square root of negative 1. And your answer here would be plus or minus 2I is one way we kind of looked at solving this one. Right, so that would be an example of like something that you should be able to do. Also, as like a easier or a different version would be if I gave you something like p at x is x squared plus 2x plus, I don't know, 7 or something. And I wanted to find this, be able to find complex numbers for these as well. So you'd set your polynomial equal to 0, like this, and you make the observation your discriminant here would be b squared, which is 4 minus 4ac, and you can see here my discriminant is 4 minus 28 is negative 24, so your discriminant's negative. So with something like this one, are you following along, Yusria? You got this? Okay, so with this one here, you got the square root of negative 24. You can break that up in terms of its complex number. So again, let me make some room here. Oops. Right, the root of negative 24, you can write this as the root of 24 times root of negative 1. The square root of 24, you can pull out a 4, like 4 times 6, so you could do that plus or minus 2 root 6, and then that would just be I. So this we could replace with plus or minus 2 root 6I. So I could go ahead and do that replacement. So my answer here is x is negative 2 plus or minus 2 root 6I over 2, and I get negative 1 plus or minus root 6I. That's as complex as it will get, no pun intended. So you see those two types, so nothing to fuss about, just that sort of situation. Yeah, nothing that comes to mind. I mean, not like the questions. I recall you asking me a question where like, that 1 plus I is a root and find the rest. Nothing like that. But you should know that complex roots come in pairs. Like for instance, I don't know, if I tell you the degree of a polynomial that you have is 10, right? Know that you can have 10 real, 2 real and 8 complex, right? 4 real and 6 complex, 6 real and 4 complex, 8 real and 2 complex. I should have written that as a complex there. Should be complex. And lastly, 10 real roots. I mean, that's about it. So something like that. That's all I can think of. Isla. Hello, Isla. Yes, nothing too in-depth. Super simple. This is as deep as it gets. How I determine these, Yusria, is complex roots come in pairs. So they got to be in groups of 2. Emery, I'll get to your question in a second. I'm assuming that's Emery. But I'll get to that in a second. Is that good, Yusria? So this is Emery wants page 186, number 3. So please make, oh, by the way, there's some, I had put these on here. These are just some questions. I had mentioned them to you guys in person. I talked about it as well. If you're looking to, the remainder theorem, solving for A and B's and the variables, I would take a look at these if you can. Take a peek at those tonight. I think we did some examples in our test too. Sure thing. Leanne? Leanne? Is this Leanne? Yes. Yeah, we can do that. All right. So we're good with this. We can come back to those too. I thought I mentioned that. Okay, page. Yes, Isla. Yeah, you got it. So some observations, like with the exam, that I think will help you guys out, is please make sure you know how to do every style of problem, right? So I'm sorry, not every type of problem, right? Don't forget to study solving trig equations, right? Don't forget to go through those and be able to solve trig equations, solve your logarithmic equations, your exponential equations, know the properties to get to the equations as well. Like I said, there's nothing like overly complicated or tricky on the exam, but it covers everything. And it's your first exam. You've written, like, your first time writing an actual exam in many years. So make sure you do a thorough review. You don't forget how to solve those questions. You got it, Yusria. You got it. Okay. Emery, 186, number 3. So with this is Emery, you asked number 3. I'm assuming you just wanted like A and B. No heating or cooling is on. No. Michael Taylor. Okay, so Emery, this one here, if you take a look, right away, like if you were to tackle this problem, let's say you get something like this on the exam. I would first look to see, is there a GCF? And there's no GCF. Then I would look for factor by grouping. I do not see factor by grouping, difference of squares, sum of difference of cubes. So I'm going to go right to the rational root test. Now these numbers are a little bit large. So, let's see how far we go here going through these. But is the root nasty on this one? This is 72. You can break it up into 9 times 8. So this is like 3 squared times 2 cubed. So you can start to go through it like this, like you got plus or minus 3, plus or minus 4. Does a root pop up soon here? Plus or minus 6, plus or minus 8. You kind of go through all those combinations, and then with the plus or minus 1, plus or minus 2. So for myself here with this question, it becomes too long of a question to start to test you guys on this on the exam. The rational root test is yielding like too many places to look. So I wouldn't. I mean, I bet the root happens fairly soon. Does anyone know what root you get for this one? I bet it's a pretty one that's like fairly soon, like 2 or 3. But do you understand, Emery? So like with this one here, I wouldn't. Thank you, Dia. -8. Oh my goodness. Yeah, I mean that's not a good exam question because you would be fussing forever. This is not ideal question in terms of that. I did assign it for just messing with the rational root test, but because it's an online help thing and the exam's tomorrow, I wouldn't fuss with all of it now. You get it though, Emery? So once you do -8, thanks, Dia, you have a quadratic, and then it's just a grade 10 math problem from there. Emery, do you want me to solve it with the root of -8? Where is Emery? Yeah, thanks. I don't know what that means. Do you want me to solve it? Yes? Yes, you would? At the with a -8? Je suis confused. Okay. Good. Okay, part B here, though, is a fine question to ask. I can go through it. So for part B, you're asking Emery, it's x minus 7 cubed plus 2x plus 3 also cubed. Okay, so right away, I bet you saw this as sum of cubes question. So if this is a sum of cubes question, this is my x, and this is my y. So this is going to be x plus y. And then you're going to have your, right, like the formula I'm mimicking is x cubed plus y cubed is x plus y, x squared minus xy plus y squared. And keep in mind, this formula right here is not on the formula sheet you guys are being given. So make sure you know it. Right, so this is my x, this is my y, that's your x value squared minus the product of your x and your y, and then plus your y value squared. So that's kind of the initial breakdown. This will end up being 3x minus 4. And for this one, we'll just have to expand it all out here. And again, please let me know if you see any calculation mistakes. Okay. So I went ahead and did x minus y, x plus y, x squared plus xy, x squared minus xy plus y squared. Just kind of following this formula here. So we get, 3x minus 4, and then you square this. So square the first time, second time, square the last. So I'm getting, 3x minus 4. And this is x squared minus 14x plus 49 minus 2x squared. These two will simplify to become minus 11x. So when I distribute that, I get plus 12x plus 21. Here, so is that right? Plus 21. What do we have? X squared with a minus 2x squared with a plus 4x squared. I'm getting 3x squared here. Collect up the purples. Minus 14x. And this comes out to be minus 3 plus 9x. Is this good? Am I, no, everyone's following along here? There's a lot of algebra here. And this is what, 60, 70, plus 79? Really? Is that right? 60, 70. Okay. So this, what I got for this one so far. And you can do a quick check here if you like. And you'll find out that this is less than 0, and we're done. Just 4/3 is the only root. Okay, so there's that one, Emre, since you were asking. Good, good. All right. Check it off. All right, page 138, number 12. So who asked 138, number 12? Who am I talking to for this one? Me. So, a turning point is when you go from like an increasing function to a decreasing function or vice versa. So, you know, maybe I want my function to go like this, but then I hit, right, it's like increasing, right, and then it, at this value here, right, we now have a decreasing function, right, at around -2. See, then it could do something like that. Do you know what I mean, Leanne, with this one? Right, it could go like this perhaps. Increasing, then it becomes decreasing function. Then maybe at this value it goes back up to increasing function, and then decreasing as well. You could do something like this. In this example here, I kind of made it look like an even function. It's not. By the way, if you have an even function, this is just a side note. If you have an even function, don't forget, like, the roots will bounce. Like if you have, let's say you have a root at 10, then my second function has to have a root at -10 if you have an even function. They have to be on opposite sides. This is a side note, but I just thought I'd mention that. Yeah, and that's the idea with this one here. And these would be your turning points. Turning point, turning point, turning point. All right, thank you. Okay, good question. If you're, you know what, if you're looking for more to practice there, I think, let me see. You guys probably aren't looking, but I know that the page right before that, Leanne, has a couple of questions too to kind of practice. Like, actually right above even, there's 10 and 11 on there. Just right above if you're kind of looking for other ones of that style. All right, very good, very good. All right, okay, Michael wanted 242 4B. So Michael, for this one here, what they're getting at is it's a two-sided inequality, but the idea here is you're essentially want to get, I want to get x by itself in the middle. So what you can do with something like this is you can distribute that minus sign. And then if I want to get x by itself, the first thing I'm going to do is get that minus 1 out of the way. So I'm going to add 1 to both sides of the equation. And because you're adding 1 to, when you're adding 1 to both, so across, I should say, not the equation, but when you're adding 1 across the inequality, you're adding that to every single part of that inequality, to which this becomes minus 3 and 6 now. This should be an x still here. Right? And then now, if I continue this question, I want to solve for x. I'm going to go ahead and divide across by minus 3, and this becomes 1. And that'll switch the inequality sign like we've talked about before. And that's a negative, sorry, it should be a negative 2. Right, so if I go ahead and divide across by negative 3, this becomes 1. This becomes negative 2. And this inequality changes signs. So now this becomes a negative 2 to 1, written properly. All right, and then below that, check, 446B. Michael, you're 446B too, right? Page 446B. Correct. So for this one here, oops, sorry. Cotangent of x is obtuse. For this one here, Michael, like the idea here is they give you the cotangent of x is negative 7 over 24. That means the tan of x is like negative 24 over 7. So your tan function is negative in sort of 2 quadrants, right? Your tan function is negative in these 2 quadrants, but because they told you that your x value is obtuse, that means that the triangle they're referring to like your x value is in this quadrant here, because this is between your 90 and 180 degrees, is the idea. Is that good, Michael? So now you're solving this triangle, and this is opposite, this is adjacent, and what do they want in this one? Oh yeah, sine it and all that stuff. So in this case here, you can go ahead and find your hypotenuse. Let's go ahead and do that. So this is h squared is 24 squared plus 7 squared. Oh, you're good. Okay. Yeah, that's all that they're getting at to solve it. I don't think there's anything else here that would be tricky up. It should, from there, it should flow pretty cleanly, obviously. Good. You guys are probably sick of doing math. You had to do it the whole weekend, eh? Or at least have it on your mind. Isla says, for the double-sided inequality, could you break it into two cases in the beginning and do it that way? Yes, you could. Yeah, you could, Isla, for sure. All right. Leanne wanted something. Where was it? Page 35, 331, 35, and 36. 331, 35, and 36. Yusria wants page 310, 6. That's the Algebra and Trig book. And 280, 26. A 102. Oh my god, what is happening? Oh, wait, 310 number 6 is from Algebra. Oh no, 310 number 6 is from Nelson. Page 280 number 26. I gotcha. Okay, and then Leanne wants number 102. I'm assuming that's from Algebra and Trig. From page 280. Hello. Let's see. I'm confused. So oh, you didn't quote the... Oh, man. Page 331, Algebra and Trig. 35, 36, and 102. Okay, let's check it out here. 35. Oh, I remember this question. This is a deep cut, Leanne, this one. This one here, if you want to solve this, I'd get rid of the, kill the fraction. And distribute that t value. At this point, the trick was with these questions, and I mean, there's like value in this trig equation. Like the idea here is like, even like if I gave you something, remember if you had something like this, let's say, I'm just making this question up, but if you had something like this here, the strategy was you could multiply across by 2 to the x, and you end up getting 2 to the 2x, plus 1 is 4 times 2 to the x, then you can treat it like a quadratic. And it's the same strategy with this question here, if you guys recall. I didn't assign this question, but Leanne kind of like dug it up, and it was one we kind of talked about and came back to. But if I multiply across by e to the x, you get e to the 2x plus 1 is 2 times e to the 2x minus t, right? Because e to the x times e to the negative x is 1. So in this question here, I'm assuming I'm trying to solve for x, so I'm going to kind of group together the x's the best I can, and then factor out a e to the 2x. You remember this? Right? And then you can divide it out. And then we would take the ln of both sides. And we done. So I'm getting x as a half here ln of that 1 minus t. Yeah. Now, I mean, the value in this question that Leanne is asking is just to remember this technique. I don't, not looking to put that question of this difficulty on the exam. But again, it's all difficulty is subjective if you don't know how to do the technique, right? So there's that. But if I were to test you on this technique, I would choose like this question. I made this one up, so the numbers probably won't be pretty. But this idea is far simpler than to have you slug through this. So you know. Okay, so like I can forego 36 if you don't mind, Leanne. It's the same strategy. Flow's just the same except you change the e's to fives. And yeah, sure, Michael. I'll get to that one as well. I got to do 102 for Leanne. Is this good, Leanne? We're good? 102? Okay. 102. Find the ordered pair. What is she up to for? Log 16. 27. Why are you doing this question here? Look to you. So, no, I know. This is a fine question. Nothing wrong with it. But if you look at this one here, this is one I had assigned before. Again, another log property, a lot of times you guys forget, is a log a of x is x. Remember this log property? So that's kind of what I want to do with this question, is I want to like use that log property, but I can't because if you notice here, well, it's this exact question, is it on the exam? No. The log property may be on the exam. So like, let me set it up just to get, I want to make sure I cover that technique. But like, here's something that you might have forgotten, right? Like I want to get a 4 here. I don't have a 4. I have a base of 16. So you can do your change of base formula, right? Log of the base I want of the top divided by log of the base I want of the bottom. So this is what log base 4 of 27 over log base 4 of 16 is just 2. So I can rewrite this as 4 times 1/2 log base 4 of 27 is 2 to the x times 3 to the y. And then I can go like this. But yeah, this question is not on the exam. But you can do, then I can finally do that property. This becomes 27 to the half is 2 to the x, 3 to the y. And then you can solve it from there. But the thing I just want to remind you guys of is your log property. And then, if you need to change the base, you can quickly change the base. Got it? Got it. Thank you. Were you guys disappointed about the snow day? Very disappointing. Could have been done. Page 510, number 12A. All right, Michael, let's check this out. 12A. Yeah, Michael, this is one I was like just talking about. Here, if I want to solve this exponential equation, Michael, what you'd do is you'd multiply it across by 4 to the x. So it was the same strategy that I used with Leanne's question here, this kind of messier one. The same thing. So if I look at something like this, you multiply across by 4 to the x, you get 4 to the 2x plus 6 is 5 times 4 to the x. And you can bring everything to one side. And then you can treat this like a quadratic. You remember this? right? So this is really just like a, your quadratic that we usually have here. Wow, see, look at Michael, just gets it, just got it from here, right? And then you would solve each of these. Michael, while we're at it, just I know you said you got it, but there's no solution on this side. You see that? No solution on that side. Right? I have a exponential growth on the right hand side. It's never negative. It's your exponential growth functions look like this. They're never going to be below the x-axis, so there's no solution on that side. This, you take the ln or log of both sides and you can solve. Okay, there's that one. Oh, what's Isla asking? Isla says, no rationalizing denominators on the exam. No, there's no questions where I say rationalize the following expression, no. Okay, U3 is asking for 310 number 6. You guys are asking very different questions than period 1. Very interesting. Okay, so in this question here, it says, how can you determine the equations of all vertical and horizontal asymptotes without graphing the function? All right. So they give you this rational function, ax plus b over cx plus d, and they ask you to, they just ask you what is the vertical and horizontal asymptotes. If I have a vertical asymptote for a rational function, that occurs when the bottom is 0. So therefore, when is cx plus d equal to 0? That's when x is negative d over c. So if x, the vertical asymptote for this rational function is negative d over c. That's your vertical asymptote. The horizontal asymptote of this function occurs when the top is 0. So when the top is 0. That happens when x is equal to negative b over a. How did I get that? I just set the top equal to 0 and solved. And you get negative b over a. So this rational function has a vertical asymptote at negative d over c, a horizontal asymptote at negative b over a. We'll give you the horizontal... oh, sorry. Not horizontal. I'm sorry. That's a root, not a horizontal asymptote. They didn't... What did they ask? Did they ask for roots? Oh, sorry. They asked for horizontal. This is a horizontal. Wrong. Vertical asymptote is correct. That's when x equals negative d over c. Your horizontal asymptote happens, if you notice, your horizontal asymptote happens if the degree of the top and bottom are equal, which they are in this example. You divide out your leading coefficients. So my horizontal asymptote here is y is a over c. And you have your horizontal asymptote here. U3, are you there? And as we talked about, give me a, throw something in the chat. Make sure you got this. Yes. Thank you for the... the box question? Yeah, I mean, boxes are, they're nice, box questions. Nice question. People use boxes. They're practical. Could be a practical question. I wouldn't fuss with it too much, but, I'd know the box question. It, like, in general, in life, it comes up. For B, they ask you, when does this function have a hole? Yeah, yeah. Tareem's done now with functions. She's probably still on the live stream, the learning more functions. Yusria, you asked this question. Can you engage me on this, or should I move on? We discussed this. Where's Dia? Isn't Dia supposed to be putting some things in the chat to keep this going? Nope. Kinlaw, nope. Caitlin, nope. All right, I'm moving on. That's it? Hey? So, all right. 20, 280, 26. Yeah, I was supposed to get something there. 280, 26. You sure did not want B. Oh, thanks. Yeah. 10 out of 10. I hope you guys get 10 out of 10 on this exam. Ah, yes. Thank you, man. I'll do the same tomorrow when you're writing your exam. Okay, I'll do the pep talks too. You got this. Nope, too bad, Yusria. I did all of A. You didn't stop me. You let me go through all of A. Then I called your name like 5 times, didn't respond, and now you want B. Nope. Nope, not doing it. Maybe after I'm done 26, I'll go back. We'll decide. We'll see. Oh, yeah, heavy metal music. Yeah. Yeah, Isla, you definitely listen to heavy metal music for sure. So again, some tips for tomorrow's exam. Just make sure you know how to solve the types of problems, right? Like make sure you know how to sketch polynomials, end behaviors, inequalities of polynomials. Make sure you know how to graph rational functions, solve rational inequalities. Make sure you know how to solve exponential equations, logarithmic equations, and your trig equations, right? Make sure you know how to do those things. Oh yeah, tomato music. I gotta listen to that again. The exam is 2.5 hours, Jack. Okay, so for 280 here, this is just a factoring question. This will factor to x plus 4, x minus 3, x minus 4, x plus 4, squared and squared. And for 26 here, it says state the multiplicities of each. So multiplicity, this has a root at 0, multiplicity of 2, root at negative 4, multiplicity of 2, root at 3, multiplicity of 2, root at 4, multiplicity of 1, and a root at negative 4, multiplicity of 1. Add up your multiplicities, should add up to the degree of the polynomial. This becomes 2, 4, 6, 7, 8, degree 8 polynomial, and that's what we have. That's the idea with the multiplicities. Is the functions and relation stuff going to be more multiple choice type questions? Sorry, Isla, I cannot disclose this information to you. Thank you. Well, we'll go back. We'll do 6b here for Yusria. So for 6b Yusria, they ask you under what conditions do you have a hole in the graph? To have a hole in the graph, what would have to happen is the root of the top has to equal the root of the bottom. So it would have to be the case that when the top is 0, the bottom has this. They both have the same 0. So the top of this expression has a 0, right? The 0 of the numerator is negative b over a. And that would actually have to equal the 0 of the denominator. So negative b over a would have to equal negative d over c. Or in other words, like BC has to equal AD. And that would be the relationship that you need to happen. There's not like a finite answer, but that's the relationship you'd have to have such that you have a hole in the graph. You know, as a practical example, like you have 3x minus 1 as a root. So the root here is a third. And then, I don't know, they give you like 15x minus 5. Like let's say you have something like this. Both of these have the exact same root. This has a hole at a third for your 6b. All right. Anything else? Are there more questions? I think I'm done. Is this it? Did I go through them all? Yep. Sibra. All right. 441, number 2 and 7. Oh, geez. Geez. What is this? Oh, dear God. All right. I'll get to that in a second. 441, number 2 and 7. Oh, yeah. Let's do this one. Cos 2x plus 2 sine squared x minus 3 is negative 2. X is between 0 and 2 pi. So for this one here, Sibra, the idea, this is solving trig equations, which you should know for the exam, involving identities. So in this case here, I'm looking to solve trig equations, solving with identities. So in this idea, I need to get a common function here. I've got cos of 2x and sine squared of x. Well, what I'm going to do is, I know you have 3 formulas. I know the cos of 2x is cos squared x minus sine squared x. It's also equal to 2 cos squared x minus 1. It's also equal to 1 minus 2 sine squared x. So I'm going to choose this one here. And the reason I'm going to do that is now this is all a function of one thing. So I can change the cos of 2x to 1 minus 2 sine squared x plus 2 sine squared x minus 3 equals negative 2. Does that make sense, Sibra? So now what happens is these completely cancel. And I get negative 2 equals negative 2. Did you get this, Sibra? Oh, good for you. So you end up getting here infinite solution. Like this is always true, right? This is always true. So this is infinite solution. That means the solution set is from 0 to 2 pi because that's where they had the domain go from. So it's everything. This is an identity at this point. At this point, we have an identity. Smarty. What a smarty. Oh, smarty. Basic. Says Sibra. 2 is 1.5. Number 7, you were asking here, we want to solve this one. So this will be, what, 3 sine of x is minus 0.5. The sine of x is negative 0.5 over 3. This is nothing clean. Negative 0.5 divided by 3 is not that great. So To solve this here, you want to look at your unit circle. The question was given to us in radian measure, so make sure you answer it in radian measure. And we want to go below the x-axis here, so these two values, or the two spots where sign is negative. So if I take the sine inverse of negative 0.5 divided by 3, I end up getting that my x value is approximately negative 0.17. So that means that the distance from here to here is 0.17. So that means this distance here is also 0.17. So the answer has to be positive orientation, which means it's going this direction, right? So I have to give these two answers in terms of this direction. So it's going to be all the way from here to here is pi, plus this little bit, which is 0.17. So my answers are going to be pi plus 0.17, or I'm going to go all the way to here. And to get all the way to here, you can go all the way around, which is 2 pi, which we know, and then back up 0.17. So you can go 2 pi minus 0.17. And then these two values here, Sibra, will be your answers in radian measure. Now the textbook will probably equate, like they'll actually calculate them. And then they'll get like 3.31. And here it's 2 pi minus 0.17. And I get 6.11 as the two value. That should say 11. Looks like 61. 6.11. Those two numbers. Sure. Did I assign that one? I'm just curious if I assigned it. I do not remember. So they essentially, Emre, you're solving this equation here. Emma, are you with me so far? Now this is in, they end up giving you, your calculator gives you, when is sine going to be minus a half? That's at your 30-degree cut, or pi over 6. So for our purposes, it's going to be 11 pi over 6 or 7 pi over 6. Pi over 6. So multiplying across by 6 and dividing by pi, I end up getting here, what, 7 and 11 for this t values. Multiply across by 6. Divide by pi, you get 7 and 11 when time is 7 or 11, whatever this is measuring. But now the period of the function here, we want to keep adding the period of the function until we use up our space that they gave us. Right? If you notice here in number 5, t value is between 0 and 24. So just add it, the period of the function is 2 pi divided by, in this case here, you're going to divide it by pi over 6. Right, so we end up getting 12. The period of this function is 12, I believe. That should work out. You end up getting 12. So the next value of interest would be, what, 19? And then 23. So these are the sort of 4 values here that they want you to examine. And this question is asking, consider a day when you start at midnight, determine when the depth of the water is 3 meters. So if you're starting at midnight, they've got like 7 a.m., 11 a.m., and then this would be 7 p.m. and 11 p.m. Right, 1900 hours is 7 p.m., 2300 hours is 11 p.m. Is that okay? Okay, so page 437, numbers 17 and 20. 377, numbers 377, number 10b. 241, number 9. This is a lot of course. 242. 489C, 441. What? All right, what is going on here? No, this is not a typical sign question. Oh, I see. Ali, you separated them with a little thing. Okay. So 17 and 24, 37. Number 19, page 377. Oh. That's my mistake. 377, number 19. I see. All right. 241 10D. 241 10D. I'm just trying to write down Ali's questions. They're like really hard to read here. 9, number 242. Number 9. Yeah, I'm done writing these down. Okay. Ibrahim, what's he asking here? Ibrahim. 510 10D. Sure. It's not easy. All right. 510 10D. Not 9x squared is 27. So for 510 10D, what you want to do is you want to get everything in terms of a base of 10. So this will be 5 to the x. Then this will be 3 squared to the x squared is 3 cubed. So you just want the same base. You want to make all of these base of 3, right? 3, 9, and 27 all have a base of 3. So I kind of rewrote 9 as 3 squared and 27 as 3 cubed. So now this becomes 3 to the 5x times, this becomes power to a power you multiply, this becomes 2x squared is 3 cubed. So I multiply with the same base you add, this becomes 2x squared plus 5x is equal to 3 cubed. Then you can drop the base. And you just, in this case here, Ibrahim, bring everything to one side. And then you factor. The first strategy. I saw some people, multiplying across by expressions and that sort of thing. In this case here, you can multiply across by 5. It doesn't change the inequality, but you should, in general, bring everything to one side and get yourself a common denominator would be the best strategy here. Now, in this case here, I can just factor out a 2x plus 3. I would probably do that, actually, in this case. Factor out a 2x plus 3 over 5. It's a little easier. And I end up getting x minus 4 left over minus a 1 here. It's greater than or equal to 0. So I end up getting 2x plus 3 over 5 times x minus 5 is greater than or equal to 0. Draw your number line. The two roots are negative 3 over 2 and 5. And then, like I said, pick something in each interval. So pick something greater than 5. Again, these were mistakes I saw. People not being able to finish the equation, not bringing everything to one side, and then solving. These are all common issues that was seen. Once you get here, you find your roots, right? You pick something greater than 5, so like 100, whatever you like, and you'll see it's positive. I'll see this is negative, and I'll see this is positive when I sub it in. I want to know when this is greater than or equal to 0, so that's these two intervals here. So this goes from negative infinity to negative 3/2. Now I have equality here, you'll see, so I'm going to put a square bracket to include that endpoint, because that's a value where it's equal to 0, and then square bracket 5 to infinity. And that's like how you would tackle this one. For 241, 10D, and then 242, number 9. 242, number 9. Oh, the box question. Very nice. A box holds an expensive pen. Square ends in a length 13 cm. Okay. So here's your box question you guys were asking me. You've got this box drawn here. So we've kind of gone through this idea before. You have to cut out these, squares out of each corner to solve this. And the volume of the box is told to us at 60. And it says the length of the box, let's label this as the length, is 13 centimeters longer than the width. So if this is my width, the length is, you take your width and you add 13. Right? The length is longer. So it says that the length is 13 centimeters longer than the width. So you have this sort of setup here. Now this one actually, sorry, as I keep reading it, it's already constructed. So you're not actually creating the box. This is a box holds a pen. So for this one, Ali, they already made it for you. So we're actually not cutting anything out, which sort of makes it a bit easier. But the idea here is you have a pen. You guys will probably all do this. And I know if this is my width plus 13. I actually hope this doesn't happen to any of you. I hope that you don't buy an expensive pen and keep it in a box. I hope this isn't like something that you strive to achieve. So in this one here, Now it said a box that holds an expensive pen has square ends. So because the ends are square, they're telling you, kind of inadvertently telling you that this is W as well, because it's a square on that side. All right. So from here out, at least, since we'll stop here, this is your W times W times W plus 13. And you can go ahead and solve that yourself for 242, number 9. You set this up and solve. This will probably lend itself to guess and check. You could probably guess a value that would work really cleanly with it, but just by looking at how 60 is broken down. All right, so there's that one. Hopefully that's good. Let's check that off. Boom. Okay, Yusria had asked a bunch I didn't get to. 6C, 14, 240, 14D. Estimate, okay, sure. So 240, 14D. This is just an application question. It's asking for average rate of change from 2 to 7. You'll have to be a little more specific, Yusria, as to what you don't know or what you would like in this question, because the formula is just looking for your average rate of change, and then they're looking for your instantaneous rate of change. So that's going to be 5 plus h over f at 5 over h, and you just let h be a really small number. For our pre-calculus class, that's all we're kind of doing here. So those are like the two ways to get through that. Okay, yeah, you can check it out. You're just subbing in numbers, so you're just making a calculation mistake. Since we don't have much time, I won't go through it further than that. You just plug it in numbers and see. Then yeah, it would be a calculation mistake, because it's just a polynomial as well. Degree 4 though. But those are the formulas. So next we've got 240. Oh wait, 12 and 18. Oh, for 12, do you actually need a graphing calculator? 240 number 12, let me see. Did anyone solve 240 number 12 just algebraically? Oh no, eh? Plus x squared. Okay, perhaps then you actually can't. Are the roots clean, Yusria, that you get then? You said you couldn't solve it with, you needed a graphing calculator for it? Did you solve it like with, were the roots clean when you actually did solve it? Well, let's bring it to one side and see. I get minus x cubed. Oh, negative 2.31, okay. Minus 3x squared. Let's take a quick peek and see. What, plus 2x minus 4 is greater than or equal to 0. Minus 3 plus 2 plus 1. And then I get x cubed plus 3. That should be a squared there. X squared minus 2x plus 4 is less than or equal to 0. Yeah, so yeah, if you take a quick look here, if you try, you'd have to do the rational root test, and the roots to try here are plus or minus 1, plus or minus 2, plus or minus 4. If none of those work, then you have no rational roots, which means the roots are all irrational. The degree of this is odd, so I know it's going to cross the x-axis, right? We know it crosses the x-axis, so in that, it must have an irrational root. So that's probably what you're seeing when you're solving your SRIA. So yeah, I guess you did need a graphing calculator for that one. And number 8, what's that one? Okay, any other questions? 441 9C, sure. 441 9C. Oh, you know what, Ali? For 441 9C, the only thing you got to do here is just break up the sign of 3x. Like, write it as the sine of 2x plus x, and then go ahead and use your formula. So, like, sine 2x cos 2x plus sine x cos 2x. And if you've answered A, B, and C, you already know what this is, and you already know what this is, and you definitely know what these two are, so you can just sub it all in and get your answer for 9C. So that's all they were getting at for the 3, like sine of 3x, is just to kind of do this sort of trick here. Boom to boom. Oh, what is that? Oh, you wanted 9. Oh, sorry, that's 9D. 9C, sure. 9C, they want the cos of 2x. Oh, okay. Well, 9C is fairly easy as well. If they want the cos of 2x, I know that that's 1 minus 2 sine squared of x. But they tell you in the question the sine of x, sine squared of x, is given to you as 4 over 9. So the sine of x is plus or minus 2/3. Now, in this question, they tell you that the x value itself is, like in the question, they say x is greater than, like they tell you you're in this quadrant in the question, right? Because it's greater than pi over 2 less than pi. So that means that your sine of x here is 2/3. It must be 2/3. So you just sub it in, and you can find the cos of 2x. Were you able to solve 9D without answering 9C? You know what, Alim? I got a different version of the textbook. It's all jumbled up the order. Sorry. That's why it's mixing these up. Okay. You want cos of x over 2. You know what? My textbook doesn't even have that, but I can answer it for you. They want cos of x over 2? Sure. If you want cos of x over 2, you know cos of... Like, I know the cos of 2x is 2 cos squared x minus 1. So therefore the cos of x is 2 cos squared x over 2 minus 1. Right? So therefore the cos of x plus 1 divided by 2 is the cos squared of x over 2. So the cos, you following, Ali, is going to be equal, it'll be the positive root here. This is your half angle forms. We didn't really formally derive them, but these are your half angle formulas here. So you'd kind of use this fact, like, oops, sorry. You know the cos of 2x is this, so therefore I can kind of let it cut everything in half. You still have that relationship. And then I isolate it for... Oh, sorry, guys. 1 second. Anyways, you see that, Ellie? Boom, 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 boom. All right, any other questions? Alrighty. That's 9. Yes. Okay. All right, what's next here? 240. Hi, Yusria. 240 number 8 is 4 parts, so I'm not sure what part you want. For 510, we've got 51012B. 51012B is a quadratic, so just like the question I went through with Michael. So let's see, that'll be, just to help you out with that one, 510 number 12B, that's just a quadratic equation. So this will be 8 times, what is this, 5 to the 2x, plus 8 times 5 to the x equals 6. So you'll just treat this like a quadratic. This will be 8t squared plus 8t minus 6 is 0. I divide across here by 2. We get 4t squared plus 4t minus 3 is 0. We have a quadratic here. Just bring the 6 to the other side. Let t equal 5 to the x, and you have yourself a quadratic 8t squared plus 8t minus 6. And then you can go ahead and solve from there, just like 12a actually, same style. Okay. All right. No, that's 5 to the power of 2x. In 12a, it was 4 to the negative x, and then I multiplied it across by 4 to the x. All right, guys, that's it for me. I have to go, so we'll stop it here. Good luck tomorrow. Should be fine. And I will see you guys tomorrow, but I unfortunately have to leave. But we'll stop here. This should post. You guys can check it out. But like I said, just make sure you know all the types of questions, solving all these sorts of ones that we've gone through, kind of covering these basic ideas. Solving logarithmic equations, exponentials, your trig equations. Don't forget, we didn't have a formal test on solving trig equations, so you're definitely going to see that on the exam tomorrow. All right, so good luck tomorrow, guys. I'll see you.